For nearly half a century, it has drifted alone through the black silence between the stars. Its voice faint. Its mission eternal. Voyager 1, the farthest human creation in existence, is about to cross a boundary no other machine has ever reached. 1 light day from Earth. That is the distance light itself travels in 24 hours. An almost unthinkable gulf where every whisper from humanity takes a full day to arrive, and another to return. Launched in 1977, when the Internet didn't exist and Pluto was still a planet, Voyager 1 has outlived the scientists who built it, the computers that guided it, and even the expectations that defined it. It has seen the storms of Jupiter, the rings of Saturn, and now nothing but infinity. But as it prepares to cross this invisible threshold in 2026, engineers at NASA have begun to notice something strange. The signals returning from the probe have grown slower, weaker, and more unpredictable. Is it simply age, the last breaths of a dying machine? Or could something else, something beyond our understanding, be whispering back from the dark? Because once Voyager 1 moves 1 light day away, it will no longer be part of our world. It will become a messenger adrift in eternity, carrying our story engraved on a single golden record, and perhaps, finally, no longer alone. In the vast silence beyond the planets, a single machine continues its slow march toward immortality. By November 2026, Voyager 1 will reach a distance no other creation of humanity has ever crossed, 1 light day from its home world. At that unimaginable range, a radio signal will take a full day to reach it and another to return. Communication will no longer be a dialogue. It will be an echo across time. When Voyager 1 left Earth nearly 50 years ago, its mission was expected to last only 5. It was designed to take advantage of a rare planetary alignment, a gravitational dance that occurs once every 176 years. By slingshotting around Jupiter and Saturn, Voyager 1 gained enough speed to break free from the solar system's plane, taking a faster, steeper path than its twin, Voyager 2. Moving at 38,000 miles per hour, nearly 17 kilometers per second, it became the fastest, most distant human-made object ever built. For decades, it has been silently pushing outward, beyond Pluto and the Kuiper Belt. In August 2012, it crossed the heliopause, the invisible frontier where the Sun's influence ends and interstellar space begins. In that moment, Voyager 1 became the first artifact of human civilization to leave the Sun's domain. Today, it resides over 15.7 billion miles from Earth. By late 2026, that number will pass 16 billion, marking its arrival at 1 light day. That distance is not just a measurement, it's a symbol. It marks the limit of real-time connection between humanity and its oldest explorer. Every transmission must now be planned carefully, every command pre-programmed days in advance. Each conversation with Voyager spans 48 hours. Monitoring this fragile link is NASA's Deep Space Network, a triad of enormous radio antennas in California, Spain, and Australia. By measuring the slightest Doppler shift in Voyager's faint, time-delayed signals, engineers can still track its speed and position with astonishing precision. Those weak, whispering pulses from the edge of the Sun's influence are a triumph of endurance and ingenuity. What began as an ambitious 5-year experiment has become a 50-year odyssey. The milestone of 1 light day is more than a scientific victory, it's a statement of human persistence. Even across the most infinite distances, our curiosity refuses to fade. Each flicker of data that returns from the dark is not just science. It is a promise that no matter how far we go, we will keep listening. Though far from any planet and operating on power levels that could barely light a small bulb, Voyager 1 remains scientifically productive. It continues to gather data from the deepest region ever reached by human hands, measuring the density, temperature, and magnetic structure of interstellar plasma. When it first crossed the heliopause, scientists expected calm, a silent ocean compared to the turbulent solar wind. But Voyager found chaos. Its sensors revealed that even beyond the sun's reach, solar storms and magnetic waves still ripple outward, shaping the interstellar medium billions of miles away. These discoveries forced a complete re-evaluation of how the heliosphere interacts with the wider galaxy. Two of its instruments remain crucial: the plasma wave detector, which records pressure waves from solar eruptions, and the cosmic ray detector, which tracks high-energy particles entering from the galaxy beyond. Together they have turned Voyager 1 into a living observatory, a 1977 spacecraft still teaching 21st-century scientists how space itself breathes. Its data not only expands knowledge but stands as a symbol of resilience. Each pulse that reaches Earth proves that even a machine built before the digital age can still serve discovery. Voyager 1 has become more than an explorer. It is a teacher, reminding us that even in the quietest corners of the cosmos, knowledge endures. When it crossed the heliopause, many imagined interstellar space as still and lifeless. Yet the data told another story, a realm alive with motion. Plasma densities rose and fell, magnetic fields twisted, and faint echoes of solar storms still rippled through the void. Even here, 15 billion miles away, the heartbeat of the sun could still be heard. The space between stars, it turns out, is not empty. It moves. It breathes. It reacts. And through Voyager's fragile instruments, humanity continues to listen, learning that beyond the edge of light, even silence has texture. Every great mission faces a final moment, when endurance meets inevitability. For Voyager 1, that moment draws near. Its heart, the radioisotope thermoelectric generator, runs on the slow decay of plutonium-238. Each year, its energy output drops by about 4 watts. To keep the probe alive, NASA's engineers must choose which systems to preserve and which to shut down. Already, non-essential instruments have been silenced so that a few core sensors and communications can endure. In 2017, engineers reactivated backup thrusters dormant since 1980, a feat of extraordinary ingenuity that extended the mission by several years. But even that victory cannot stop time. By around 2036, the energy output will fall below what's needed for the transmitter to operate. When that day comes, Voyager 1's signal will fade into silence. There will be no dramatic ending, only the slow dimming of a whisper that has traveled across the cosmos for half a century. For the first time since 1977, Earth will speak into the void and hear nothing in return. Yet even when its voice is gone, Voyager 1 will not stop. It will continue moving outward at 3.6 astronomical units per year, the distance from the Sun to Jupiter every 12 months, drifting farther from home, carrying the memory of human curiosity into eternity. The silence that follows will not mark failure. It will mark completion. Because the mission was never about how long it could transmit, but how far we could reach before its light vanished into the stars. Long after contact ends, Voyager 1 will still be moving, a metal traveler crossing the unseen frontier of the Oort cloud. In roughly 300 years, it will reach the inner edge of that vast sphere of frozen remnants surrounding our solar system. There, it will drift among icy bodies, ancient fragments left from the birth of the Sun. Passing through this region will take 30,000 years. When it finally exits, it will be free of the Sun's gravitational hold, moving into the true interstellar dark. NASA's trajectory data shows its path aimed toward the constellation Ophiuchus. Around the year 40,272 AD, Voyager 1 will pass within 1.7 light-years of a faint star in Ursa Minor. By then, civilizations may have risen and fallen, continents shifted, and memory itself changed. But Voyager 1 will still be out there, silent, eternal, a messenger that outlived its makers. Its aluminum skin may erode from countless collisions with dust, but that decay will take billions of years. In that sense, Voyager 1 is immortal, not because it lives, but because it endures. Beyond the last faint trace of sunlight, its purpose transforms from science into symbolism. It becomes a monument of persistence, a small craft proving that humanity once reached for forever. Inside it rests the golden record, a message written in sound and light. Waves. Wind, music. Laughter. Greetings in 55 languages. And a single heartbeat. A portrait of who we were, and what we hoped someone might one day find. Even if no one ever does, its existence means we once looked up and dared to speak to the universe. Voyager 1 is proof that exploration was never about reaching another world. It was about proving we could send a part of ourselves into eternity. So somewhere in the deep black sea between the stars, a small traveler continues to glide, unhearing, unfeeling, but still carrying humanity's first message to the cosmos. A voice in the darkness, still traveling outward, still speaking for all of us. Subscribe to our channel and thanks for watching.